Welcome to Potty. May 16th, 2020. Here's the tension that's been living in my head for weeks now. The CEO of Google DeepMind, one of the most credentialed AI researchers on the planet, a literal Nobel laureate, is publicly saying there's a 50% chance we build AGI by 2030. That's not a fringe prediction. That's not a hype merchant on a podcast. That's Demis Hassabis, the person who built AlphaFold, the system that solved a 50-year-old grand challenge in biology, saying, we might be 5 years away from machines that can do anything a human mind can do. And at the same time, if you actually dig into the technical literature, the 5 hardest problems between here and AGI are not only unsolved. Some of them don't even have a clear solution path yet. So which is it? Are we 5 years out, or are we fundamentally stuck? That's what we're going to dig into today. And I promise you, the answer is more complicated and more interesting than either camp wants to admit. Let me set the stage before we get into the hard stuff. AGI, Artificial General Intelligence, is the idea of a system that can perform any intellectual task a human can, and crucially generalize across domains, rather than just being good at one narrow thing. The current generation of AI, the large language models, the foundation models, GPT-4, Gemini, Claude, these systems are genuinely impressive. They exhibit what researchers call emergent capabilities, things that appear almost unexpectedly as you scale up training. But they are not AGI. They're extraordinarily capable pattern-matching engines. They can write code, explain quantum physics, generate poetry, translate languages. But they do not reason the way a human reasons. They cannot learn continuously from new experience the way you and I do. And their failures are often bizarre and unpredictable in ways that human experts simply wouldn't fail. The gap between very impressive language model and genuine general intelligence is the story we're telling today. So let's talk about who's making these predictions and why their credibility actually matters here. Multiple headlines across major outlets are framing this the same way. Demis Hassabis has consistently maintained a 50% probability of AGI by 2030. CNBC ran a headline that says, human-level AI will be here in 5 to 10 years. DeepMind CEO says. Axios covered him at their AI summit saying AI is hurtling toward a transformative moment. And then there's a Fortune headline about a 145-page Google DeepMind paper, a formal research paper, that reportedly predicts human matching AGI by 2030, while also flagging existential risk implications. That last part is important. This isn't just Hassabis on a stage being optimistic. His own lab is formalizing this timeline in peer-reviewed work and attaching a warning label to it. Meanwhile, a headline framing from another source notes that Google co-founder Sergey Brin actually goes further, suggesting AGI could arrive before 2030. So, you have 2 of the most consequential figures in the history of the internet and AI converging on the same 5-year window. That's a signal worth taking seriously. Here's what most people get wrong about Hassabis' prediction. They assume he's using a low bar for AGI, like maybe a system that passes some benchmark suite or beats humans on a standardized test. But from what's been reported, his bar is actually exceptionally high. We're talking about genuine scientific discovery capability. Not can it summarize a paper, but can it actually generate novel scientific insight that advances human knowledge? And that makes his 50% by 2030 estimate more striking, not less. Because if he were using a looser definition, you could dismiss it as goalpost moving. But if he means the real thing, a system that can do what AlphaFold did, but across any domain, on demand, and he still thinks there's a coin flip chance we get there in 5 years, that is a genuinely extraordinary claim. It's also why his AlphaFold Nobel Prize matters so much as context. That system solved protein structure prediction, a problem that had stumped biochemists for half a century. The Nobel Committee, not known for being easily impressed by AI hype, validated that achievement as legitimate scientific discovery. Hassabis has receipts. When he says AGI could enable 10 times the impact of the Industrial Revolution, which is another headline framing I saw that's not empty marketing. That's a man who's already watched AI rewrite biology speaking from experience. Okay, so with that context established, let me walk you through the 5 technical problems that are genuinely standing in the way, because this is where the episode gets interesting. The first one is continual learning, and it connects to something called catastrophic forgetting. Here's the core problem. Current neural networks, including the biggest LLMs, are trained in discrete episodes. You train the model on a massive dataset, you freeze the weights, you ship it. If you then try to train it on new information, like, say, everything that happened in the world last month, the network has a strong tendency to overwrite what it previously learned. It forgets old knowledge to make room for new knowledge. This is called catastrophic forgetting, and it's a fundamental architectural limitation. Your brain doesn't do this. When you learn a new skill, you don't forget how to ride a bike. Biological memory has a consolidation mechanism, particularly this process that happens during sleep, where the hippocampus essentially transfers experiences into long-term neocortical storage. We've been trying to replicate this in AI for decades. Techniques like elastic weight consolidation, progressive neural networks, memory-augmented architectures. These are real research directions inspired by neuroscience, and they've made progress, but none of them match biological robustness at scale. This is not a solved problem. This is a wide open... The second unsolved problem is chain-of-thought reasoning, and this one is particularly sneaky because it looks like it's working right up until it isn't. Chain-of-thought prompting, the technique where you get a language model to articulate its intermediate reasoning steps before giving a final answer, genuinely improves performance on multi-step tasks. You've probably seen this in practice. Ask a model to think step by step, and it does noticeably better on math problems, logic puzzles, planning tasks. The problem is that the reasoning chain can be fluent, confident, and completely wrong in ways that are hard to detect. Researchers call this reasoning hallucination. The model produces a reasoning chain that sounds internally coherent, but is actually unfaithful to whatever computation is actually happening under the hood. The model is, in a sense, confabulating its own thought process. It's like asking someone why they made a decision, and they give you a perfectly logical post hoc explanation that has nothing to do with the actual neural processes that drove the choice. And Kant also struggles badly with tasks that require genuine novelty, things that can't be solved by interpolating between patterns in the training data. If the answer requires a genuinely new idea, not a recombination of existing ones, chain-of-thought reasoning often leads you confidently in the wrong direction. That's a critical path problem for AGI-level scientific discovery. Third on the list, reinforcement learning and Monte Carlo tree search, which are actually a partial bright spot in this otherwise pretty challenging landscape. So here's the history that matters. DeepMind. Hassabis' lab was built fundamentally around reinforcement learning as the path to general intelligence. AlphaGo, AlphaZero, Mu0. These systems used RL combined with Monte Carlo tree search, which is essentially a way of exploring a tree of possible future states and learning which branches lead to good outcomes. They dominated bounded game environments, Go, chess, shogi, Atari games. But for a long time, the field hit a wall trying to get RL to work in open-ended, real-world domains. The environments were too complex, the reward signals too sparse. What's changed recently, and this is genuinely exciting, is that MCTS style search is being reintegrated into the foundation model stack as an inference time reasoning engine. OpenAI's O1 and O3 models, and DeepMind's own Gemini reasoning variants suggest that you can use search at inference time, essentially letting the model think harder by exploring multiple reasoning paths and selecting the best one, to substantially improve reasoning quality on hard problems. This is RL and search re-entering the picture, not as the primary training mechanism, but as a way to make already trained models smarter at runtime. That's a meaningful architectural shift. The fourth piece of the puzzle is model distillation, and I want to spend some real time here because the implications are often underappreciated. Distillation is the technique of training a smaller student model to mimic the output distributions of a larger teacher model. The intuition is, If the frontier model has learned something really powerful, can we compress that knowledge into a smaller, faster, cheaper model that's actually deployable in the real world? The answer, increasingly, is yes, up to a point. You've seen this play out with models like Mistral, the Phi series from Microsoft, and DeepSeek. These are models that are dramatically smaller than the Frontier GPT-4 class systems, but that approach frontier performance on many benchmarks. Recent distillation research has pushed this further. Not just output-level distillation, where you mimic the final answers, but feature-level distillation, where you try to transfer the internal representations, and process-level distillation, where you try to transfer the reasoning process itself. The result is that capability is diffusing rapidly. What was only possible on a massive cloud cluster 18 months ago is now running on a laptop. That's a democratization story, but it's also a proliferation story. And both of those have significant implications for how AGI, whenever it arrives, gets deployed and accessed. And the fifth unsolved problem, which in some ways underlies all the others, is memory consolidation at the architectural level. This is distinct from the continual learning problem I described earlier, though they're deeply related. The issue is that current LLMs have a context window, a finite amount of information they can hold in working memory at any given moment, and no persistent episodic memory that survives across conversations or tasks. Every session starts fresh. There's no equivalent of you waking up tomorrow and remembering what you learned today. Retrieval augmented generation, where you give the model access to an external database it can query, is a workaround, but it's not the same as genuine memory consolidation. The biological model here is compelling. The hippocampus rapidly encodes new experiences, and then during sleep, those experiences are slowly integrated into the neocortex, strengthened, pruned, and connected to existing knowledge. That process is why you remember important things and forget irrelevant ones. We don't have anything like that in current AI architectures at scale. Memory-augmented architectures exist in research settings but haven't cracked the problem at the scale and robustness needed for AGI-level capability. This is the one that I personally think is most underrated in public discourse. So now, let's put these 5 problems in conversation with the 2030 timeline and see what actually shakes out. One framing I find really useful. The 2030 AGI debate is not just a timeline question. It's a proxy debate about what AGI means and which of these unsolved problems are actually critical path versus nice to have. If your definition of AGI requires robust continual learning and genuine episodic memory, then 2030 looks very aggressive given where the field is today. If your definition is more functional, a system that can do the work of a brilliant human scientist in a structured domain, then the combination of better reasoning via MCTS, improved reliability through distillation, and scaling of compute makes 2030 feel less outlandish. Hassabis' own framing, based on what's been reported, leans toward the more demanding definition, which is why his prediction carries weight. He's not lowering the bar to make the timeline sound achievable. He's keeping the bar high and still saying 50% chance by 2030. That should make everyone sit up a little straighter. There's also a practical warning embedded in the Hassabis framing that I think deserves more attention than it's getting. One headline I looked at frames it this way: the 2030 AGI timeline is what Hassabis is banking on, and he's warning founders that any 10-year deep tech project started today must account for AGI's arrival mid-project. Think about what that actually means for a second. If you're a biotech company building a 10-year drug discovery pipeline, or a robotics company with a decade-long roadmap, and AGI arrives in year 5 or 6, the entire research methodology, the competitive moat, the staffing model, all of it gets disrupted mid-execution. That's not a hypothetical risk you can put in a footnote. That's an existential strategic consideration that most organizations are not yet seriously modeling. And this is coming from someone who has already demonstrated with AlphaFold that AI can collapse decade-long scientific timelines into years. He's not speculating about this dynamic. He's lived it. Let's talk about implications, because this is where the threads start converging in ways that I think are genuinely important for how you think about the next 5 years. The first implication is about the chain of thought failure problem and what it means for trust. If current systems cannot be trusted to produce faithful reasoning chains, if the model is essentially confabulating its own thought process, then you cannot responsibly deploy these systems in high-stakes autonomous reasoning contexts. That's a prerequisite for AGI-level scientific discovery, a system that sometimes produces brilliant insights and sometimes produces confident nonsense, with no reliable way to tell the difference from the outside, is not ready to be an autonomous scientific agent. The caught failure modes are not edge cases. They're systematic properties of how these models work, and solving them, making the reasoning genuinely faithful and verifiable, is not just a nice engineering improvement. It's a critical path item for the AGI vision Hassabis is describing. The second major implication is about what happens when distillation meets the capability ceiling. Here's the thing about distillation that's both exciting and sobering. It works brilliantly right up until the teacher model hits a wall. If the frontier model cannot do genuine continual learning, the distilled student model cannot do it either. You can't transfer what the teacher doesn't have. So as distillation gets better and better at compressing frontier capabilities into smaller models, we're going to hit a moment where the performance gap between frontier and mid-tier models narrows dramatically on standard benchmarks. But the tasks that still require genuine episodic memory, continual learning, and novel reasoning remain stubbornly hard for everyone. That convergence will expose the ceiling clearly. And my read is that this is actually a good thing for the field, because it will force attention toward the architectural problems that matter most. Right now, a lot of energy goes into scaling and distillation because the gains are measurable and relatively predictable. When those gains plateau on the hard tasks, the field will have to confront memory architecture and continual learning head-on. The third implication is cultural, and I think it's underappreciated. AlphaFold winning the Nobel Prize in chemistry is not just a validation of one AI system. It's a signal from the scientific establishment that AI is now a legitimate co-discoverer, not just a tool but an agent of scientific progress. That cultural shift matters enormously for deployment. It means regulatory bodies, funding agencies, academic journals, and institutional review boards are going to have to develop frameworks for AI-assisted discovery at a pace they've never had to move before. And it means the social and ethical questions around AGI. Who controls it? Who benefits from it? How do you assign credit and responsibility? Are going to arrive much faster than most institutions are currently prepared for. The Nobel recognition didn't just honor a past achievement. It opened a door that's going to be very difficult to close. Now, let me get into predictions, and I want to be really clear about the epistemic framing here. These are pattern-matching observations from someone who follows this space closely, not first principles research claims. I'm reading signals, not running experiments. With that said, here's what I think is the most plausible near-term trajectory. By 2027, I expect we'll see hybrid architectures, systems that combine foundation models with explicit search mechanisms and persistent memory modules, demonstrating substantially more reliable multi-step reasoning. The integration of MCTS-style inference time compute with LLMs is already underway, and the trajectory is pretty clear. What this will do is patch the most visible chain of thought failure modes. You'll have systems that can verify their own reasoning chains by exploring alternative paths and checking for consistency. That's going to reignite the AGI debate hard, because suddenly the systems will look much more trustworthy on reasoning tasks, and the question of whether the remaining gap is architectural or just a matter of scale will become genuinely urgent. That's not a confirmed fact. It's a plausible direction based on where the research is heading. The second prediction is one that I think most people aren't talking about yet, and it's a bit contrarian. The conventional wisdom right now is that distillation is basically solving the accessibility problem. Smaller models are catching up to frontier models fast, and eventually the performance gap closes. And I think that's true up to a point. My read is that by late 2026, the performance gap between frontier and mid-tier models on reasoning benchmarks narrows to within a few percentage points. But here's the part people are missing. That convergence is going to expose a harder ceiling. The tasks where distillation cannot close the gap will be precisely the tasks involving genuine continual learning and episodic memory, because you can't distill what the teacher doesn't have. And when that ceiling becomes visible and undeniable, the field's center of gravity is going to shift. Suddenly, neuroscience-inspired memory architectures, the hippocampal neocortical transfer models, the memory-augmented networks that have been living in relative obscurity in academic papers, are going to look a lot more relevant. The bottleneck will have visibly moved from scale and efficiency to memory and learning dynamics. And the labs that have been quietly investing in that direction will have a significant head start. Here's what I want listeners to actually go research after this episode, because the sources I've been working from are strong on the timeline predictions, but lighter on some of the technical depth. Look up the literature on elastic weight consolidation. It's one of the more elegant attempts to solve catastrophic forgetting, and understanding how it works gives you real intuition for why the problem is so hard. Look at the DeepMind papers on mu0 and how it extends AlphaZero to environments where the rules aren't known in advance. That's the research lineage that's now feeding into inference time reasoning. And if you want to understand the chain of thought faithfulness problem at a deeper level, there's a body of work on reasoning shortcuts and spurious correlations in COT that is genuinely alarming and not nearly widely enough read outside of ML research circles. The primary sources are accessible if you're willing to spend an afternoon with them, and they'll give you a much sharper picture of the real state of the field than any headline can. Let me bring this all the way back to where we started, because I think the arc of this episode actually resolves into something coherent, even if it doesn't resolve into a clean answer. We started with attention. The most credentialed voice in AI is saying AGI might be 5 years away, while the hardest technical problems on the road to AGI are nowhere near solved. And here's where I land after thinking through all of it. Both things can be true simultaneously, and that's not a contradiction. It's a description of how technological discontinuities actually happen. The problems look unsolvable right up until they're solved. AlphaFold looked impossible until it wasn't. The integration of MCTS into LLM inference looked like a category error until it became a product. The field has a track record of surprising itself. The unsolved problems I've described: catastrophic forgetting, memory consolidation, COT faithfulness, the distillation ceiling. These are real, they are serious, and they are not going to resolve themselves without genuine breakthroughs. But the people closest to the work, with the most skin in the game and the most credibility to lose, are consistently betting that those breakthroughs are coming within the decade. That's not nothing. That's actually quite a lot. If you're watching this in 2026, you're going to look back at this moment and remember exactly when the conversation shifted. When AGI by 2030 stopped being a fringe position and became the working assumption that serious people were building strategies around. The question worth sitting with isn't whether Hassabis is right about the date. It's whether you, your organization, your field are taking the possibility seriously enough to actually change what you're doing today. Because if he's right, and there's a 50% chance he is by his own accounting, then the systems we're building now, the 10-year plans, the research roadmaps, the institutional structures, are being designed for a world that may not exist by the time they're halfway complete. That's either the most exciting thing you've heard all week or the most unsettling, probably both. Thanks for spending the time on this one. It's the kind of topic that deserves more than a headline, and I hope this gave you the scaffolding to think about it more rigorously. Go chase the primary sources. The real story is always in the details.